This is an overview of IRSA's tools from June 2022, prepared for the AAS in Pasadena. So IRSA is part of IPAC, which is at Caltech. So by way of orientation, Caltech is a California Institute of Technology. IPAC is at Caltech, but it's unaffiliated with the astronomy department. We're a totally separate entity. IPAC has 35 years of experience with archives and science operations. That means that we hire astronomers and programmers, and we have a visiting graduate student 6-month fellowship. We have many jobs open right now. We also have the graduate student fellowships open right now. The applications for that are due August 13th, and the websites for both of those are right there. IRSA specifically is NASA's Infrared Science Archive, and our charter is to provide the interface to all of NASA's infrared and submillimeter datasets, meaning like a micron to a centimeter. We were founded in 1993, and we were the original home to IRSA data, which was taken in 1983. At least 15% of all refereed journal articles published today use data that ultimately came from IRSA. We have 5 petabytes of images and 240 terabytes in databases and counting. We have all-sky coverage in 24 bands. We have a social media presence both on Facebook and Twitter, although we are more active on Facebook than Twitter if you'd like to follow us. We also have an electronic newsletter that they're sent about monthly, in that we advertise new data releases, new tools, and partner events like conferences and proposal deadlines. These are also advertised on social media, but if you'd like it delivered to your very own email, you can go to this website and subscribe yourself. We also have a ton of tutorial videos. They're all in the IRSA YouTube feed, but we also promote at least one tutorial video per week on Facebook for Tutorial Tuesday. I also specifically during the pandemic have been doing sort of lunch talk level IRSA tool demonstrations over Zoom. I am totally happy to do one of these to your department, to your research team, to your undergraduate or graduate class. Just let me know. They tend to get good reviews. I seem to be doing a good job. So if you'd like me to do this kind of a demonstration for you, just drop me a line either at the meeting here, in the Slack, or send an email to the IRSA help desk and we can try and set something up. When you are done with all the fabulous science you can do with IRSA data, when you go to write it up, you should use the facility function in LaTeX to credit IRSA at the end of your paper. You should use DOIs for IRSA datasets found at that URL. You should follow the best practices for data publication in the astronomical literature, which is available at that archive number, but also it's recently been accepted for publication in the refereed literature. If you'd like to contribute data to IRSA, there's a website there that has everything you need to know about contributing your data to be served at IRSA. There are, of course, also extensive APIs or application programming interfaces that can be used to query IRSA archives via Python. And there have been and continue to be AAS workshops on using PyVO tools and other Python code. I find, however, that it is much easier to use the user interface, the web-based user interface, when you're just starting out trying to learn what IRSA has. Once you understand what we have and what you're looking for, then by all means, when you need to get up to industrial scale queries, use the APIs. But when you're just starting out, I think it's easier to use the web interface. And so most of the rest of this talk is going to be exploring that web interface, because we do have lots of really nice visualization tools that allow you to interact with the data, the catalog, the plots, and they're all interactive, allows you to explore what we have, and it allows you to explore what you need, both what you know you need from IRSA, but also allows you to serendipitously find other things that you might not know that IRSA has that can be relevant for your science. In terms of the very latest data deliveries at IRSA, there's the NEOWISE Reactivation 2022 release, the 4th release of the SOFIA archive. There's lots more spectral capability and abstract searches now. There's the 11th ZTF data release. There's a new version of several different tools that have more capabilities, especially the spectral visualization, which I'll show that in a bit. There's data discovery. The data discovery tool on the front page is now much faster than it used to be. In terms of specific smaller data sets, the Spitzer Cosmic Dawn project, which was like 11% of the total Spitzer time available, is now, their data products are available at IRSA, and the High-Gal 360-degree catalog of clump physical properties from Herschel is now also available at IRSA. So this is the main IRSA homepage, and from here I'm going to go jump on to the interactive portion of this talk. Okay, so here's IRSA's homepage. The first thing I want to call your attention to are the links down here. There's documentation here. There's the help desk link here, and there's a link to all the video tutorials here. If you click on this, it sort of gives you an overview of the philosophy of the video tutorials. Much to my surprise, YouTube still doesn't have a really good way of sorting the videos that they have. So the only thing they have is playlists. So the playlists sort of collect all the videos on a theme. And so you can sort of use them as like tables of contents. You can also search by the file name, the title of the video. Like if you want all the videos on Sophia, you can look for the ones that have 11 in the name. All of the most popular data sets are listed there. The most commonly used tools are here. But I'm going to start with this box here. This just says, tell me everything that IRSA has that overlaps this position on the sky. Right now, it doesn't deal with moving targets. It has to be just stationary coordinates, but you can put in a name, you can put in a position in any of a variety of units. I'm going to put in HD 555, and I'm going to search. It comes back with results here. It found 51 data sets. This is an image of the sky, and it's got two different search radii indicated. The cyan search radius is the region over which it searched to find matches in IRSA. That red circle is the region over which it searched to find counterparts in Vizier for the spectral energy distribution shown here. This tab has a list of the matching data sets. This tab has a list of the points used for that SED. These tables are interactive, so you can sort them and filter them. This right here is a filter icon. We're going to encounter this again and again. If you want to filter it down so that you only have images, you can do that. Cancel the filters like that. So the things that are listed here are, you can sort by mission, so that now all of the 2-mass overlaps are collected together. Then there's a CARI and composite catalogs. Gaia, you get the idea. Over here, there's a link to the data. So out of the results that it found, let me put it back the way that it was. So it found a whole bunch of WISE hits. Catalogs, it has here 2 IRSA viewer. Images, it says here 2 WISE image service. So if I click on any of these links that are here, it's going to launch another tool and pop the results of this search into it. So for example, there's ZTF hits, ZTF science exposure images. So if I click on ZTF image service, it's going to launch the ZTF image service with the results of my search on HD 555 in it. There's all the images that it found, and here's the first image in that list. If I go back over here and go to the 2-mass point source catalog, click on 2 IRSA viewer, it's going to launch IRSA viewer. I didn't use a very large search radius, so it found 2 sources from 2-mass. That's it overlaid on the sky, and then the plot is pretty boring because there's really only 2 points. Let's go back over here and let's look for something different. Let's go to the WISE image service. It's going to launch the WISE image service tool with the WISE images that it finds loaded in. So you might notice that the results here look very similar in all 3 of these tools. All 3 of these tools are using the same basic software under the hood. So they all have similar capabilities. So that if I load, say, the all-WISE multi-epoch photometry table into IRSA Viewer, it's going to load it into the same session I already had loaded with the 2-mass results. Then it's going to load the all-WISE individual exposure photometry here as well. So all of these tools have the same kind of interactive capability. It allows you to explore the images that it finds. It allows you to explore the catalogs that it finds. It allows you to interact with the images and the catalogs in this tool. But maybe the power of this is not necessarily readily apparent. Let's go back to the main IRSA homepage and let's launch IRSA Viewer from there. I'm going to put in IC 1396 and I'm going to ask for a degree. I can view FITS images. I can create a 3-color image, which I'm not going to do right now. I can also view HIPS images. If I'm interested in truly huge chunks of sky, HIPS images are the way to go. I don't want to do that right now. I'm going to search as opposed to use my image or load from the web or load from the IRSA workspace. Using this tool, I can get up to a degree, and that's what I'm going to ask for. I'm going to ask for a wise, all-wise image. Now, did you see what I did? There's a whole bunch of stuff over here. I mean, like, it just goes on forever and ever and ever. But, like when you buy things online, you can filter down this based on this. If I only want to see the wise data sets, I can click on this, and then now the stuff on the right is greatly reduced. If I only want to see 2MAS, and the stuff on the right is greatly reduced. If I only want to see ZTF, the stuff on the right is greatly reduced. I can also weed this down by saying, look, I just want the galactic projects, or I just want the extragalactic projects, or even better, if I just want, say, just the far IR data. You get the idea? You can also clear all the filters at once. You can also expand everything on the right all at once. You can also clear all the selections at once. But what I did is I asked for the wise, all four bands. So I'm going to search. So now it's come back with all 4 of the wise images that I asked for. It covers the same spot of sky. So maybe the first thing that I want to do is lock the images by WCS so that if I zoom in on one, then they all zoom together. Now the tools that are up on the upper right, that allows me to interact with the images. I can save the images, I can rotate, I can add a compass rose, I can measure distances, I can add overlays like markers and things like footprints from various missions and telescopes. We'll talk about extractions in a minute. I can zoom in and out from here or from there. I can change the color table, I can change the color stretch. I can also select a region and crop it down if that's what I'd like to do. Like, for example, if I'm just interested in this, I can get into the rectangular selection and then crop it down so that now all I have here is that one piece of the image. I can also go back to the beginning and undo the changes that I made. The layers here show all the layers that I have loaded in. Right now I don't have any layers. I can choose to overlay the wise image artifacts, but by default they're not turned on. So let's get a catalog and overlay it. So if I go here to the Catalogs tab, I can search at IRSA for catalogs, I can search at NED, I can load a catalog file from disk, I can search anywhere on the web via the VO or the VO simple cone search. I'm going to search at IRSA in WISE and then the All-Wise database, and I'm going to do the whole image that I asked for. I can choose which columns I want, but the default is fine for most purposes. I'm going to let it go and search. Okay, it took a little while to come back because there's like 20,000 sources. So you can see here that there's so many sources on the image that you can no longer see the image, right? There's so many sources. In fact, there's so many sources in the plot that it doesn't have the ability to render individual sources. That's showing you a heat map, a binned map of the sources on the sky. So when I move my mouse, it can tell me, okay, that cell represents 6 points, 6 rows from the catalog. So one thing we can do is weed down what's in the catalog. We can filter this. So let's say I only want the high signal to noise sources. I only want the ones where WISE 1, WISE 2, WISE 3, and WISE 4 are all signal to noise greater than 10. Wow, now I only have 624 sources. That's many fewer than the catalog returned over the whole region, and you can see that reflected in many fewer sources in the plot and overlaid on the image. Now this is all interactive, so if I click on a source in the image, it's highlighted in the table in the plot, and it's all interactive. If I click on a source in the plot, then it's highlighted in the image and in the table. Now let's change what's plotted. I can go to the gears, and let's say I want to make a color magnitude diagram. So for X, I can do W1 M Pro minus W4 M Pro, which is WISE 1 minus WISE 4. For Y, I can do W1 M Pro, and because this is a color magnitude diagram, I want to reverse the Y-axis so that the bright objects are at the top. Apply, close. There's a color magnitude diagram. And let's say I'm interested in the brightest, reddest source we've got, which is this one. It's that one, and it might be hard to see. So let's zoom in and go over here and make sure that we have picked here pan by table row. So now if I click on that row, which I know is this one, the image should zoom to that source, Why is it not zooming? That's the problem. Pan by table row is not turned on. Okay, pan by table row is turned on. Let's click on this. And now that's the source that's bright and red. It's now jumped to center that image, and it's that source from the catalog. So pan by table row is very powerful, but unless you understand that that's what it's doing, it can be terribly disconcerting to have the images keep jumping as you scroll around in the plot or in the table, because the images will jump. If it doesn't have to slew to center the object in the image, it won't. It'll just highlight the additional source that's in the image. The plots are pretty powerful. You can do all sorts of additional things. You can have the color of the symbol correspond to additional values. You can do some pretty sophisticated calculations. I just did a subtraction, but you can do logs and powers, and you can add errors, symmetric or asymmetric, either from a column in the catalog. Like in this case, I can add the errors in quadrature and add error bars based on that. I can use the error bars from the catalog for W1M Pro for the error bar in the Y direction. I can, change the labels on the chart. I can change the plot boundaries or the XY plot ratio. You can also add additional plots. You can make a heat map explicitly from the beginning, although if you have a lot of points by default, it will make you a heat map. You won't be able to make a scatter map if it has too many plots. Or you can make a histogram of just one column in the catalog. Now, I mentioned some of the newest features at IRSA. Let's restart IRSA Viewer. I can do that. And let's get some of the images. Let's do M101, and let's get SEIP, and let's search. Okay, so let's say that I want to study what the core looks like in this galaxy. If I go over here and choose Extract a line from the image, I can click and drag across the core. That is the values in this image across that line. That's in IRAC 1. If I shift click, that's IRAC 2, IRAC 3, IRAC 4, MIPS 24. Same line across all of these images. Now, if you want to save that plot, pin the table, and it saves that. Shift click in IRAC 2, pin that. Shift click IRAC 3 and pin that. Shift click IRAC 4 and pin that. Shift click MIPS 24 and save that. So now I have an extracted version of the fluxes along that line, including a coordinate of exactly what line I extracted from each of these images. And I can save them, and then I can do additional calculations with them later on. You can also draw different lines on each of the images. You can draw lines custom to each image. You can also, as one of the other extraction tools, extract individual points. So if you want to extract individual points from this image, you can click on all of the points you want to extract and then pin it, and it will save the catalog that you generated. By default, it comes up with a 1x1 aperture. You can change over the value over which it's averaging as you wish. Now, these are single plane images. What if you have, for example, one of these really sophisticated SOFIA spectroscopy images? Now this, let me do one image at a time. This has many planes in the image. So let me go to plane 25. So that's 63 microns. This is a pretty sophisticated data product. But if I choose now drill is available. If I choose drill and click here, that is a drill through the planes of the screen. And if I pin it, look here, it's done the units correctly. So it's got Jansky's as a function of wavelength over here in the plot and saved in the table with even the errors propagated correctly. So if you've got sophisticated data like you get from SOFIA, it can handle that kind of sophisticated data. Now, the capabilities, these are brand new capabilities, so they're not fully available in all the tools. Right now in Sophia, you can pin it and you can save it, but it won't make the plot, not yet. It will, but it doesn't make the plot right now. So if you want it to make not just this plot, but this plot as well, you have to save the data to disk and then load it into IRSA Viewer as opposed to the Sophia tool itself. There's lots more capabilities of this tool. I didn't even show you some of the time series analysis. You can do simple searches for periods using Lom-Scargel. There are other tools I didn't show you, like the Planck image service that has, again, is using the same kind of software, so you can explore the Planck data that way. So there's lots more capability, and I would encourage you to check out and explore all of the data that's here, but also explore all of the tutorials that are here. Many of them are very short videos, and so it's pretty easy to be able to go quickly through them. All of them have closed captioning where you can slow me down, rewind me, replay me as often as you need to. If you have a specific question, just let me know. Send us an email at the help desk right here, and we'll be happy to respond. If you have a specific suggestion for a video tutorial, let us know, and we may be able to get a video done for you pretty quick.